All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to have to do remove, replace, reduce. So remove the 9, you're going to have x squared minus 6x plus 9. And then when you factor x minus 3 times x minus 3, replace the 9 in front of your x, in between the parentheses and the x, and then reduce. And so you should have 3x minus 1, 3x minus 1, or you can make it 3x minus 1 squared. Okay, so that's for the factoring. For the math knowledge question, they tell us that we have this side length that is 14, and we want to know how long is GH. So you're going to want to use your law of sines on this one. Hopefully you're familiar with law of sines. You should have learned it last year in pre-cal. My students learned it in geometry as well, but most geometry teachers don't cover it in geometry. You're going to do the side length over the sine of the angle opposite it. So the sine of 72. And then we're looking for GH over the sine of 45, because that's the angle opposite of GH. And so then you're just going to cross multiply. So GH equals, GH times the sine of 72 equals 14 sine of 45. And then you divide by sine of 72. Now, when you plug that into the calculator, you need to make sure that you are in degrees. If you're in radians, you're going to get a funny answer. So 14 sine of 45, close your parentheses, divide by sine of 72. And if you were in radians, you'd get like 46, which clearly is not right because it's going to have to be less than 14 since 14 is opposite the largest angle. So if you were in radians, hopefully you would see 46, see that it's not even up there, and then go look at your calculator from there. So you should get 10.4089, and so B is going to be the answer you'll pick. Okay, so we're looking at lesson 24 today. We're doing the new notation for the definition of the derivative, and then we're going to look at the derivative of x to the n. So the new notation for the definition of the derivative, remember there were two people I told you that invented calculus. One of them used delta x and one of them used something else. And then we're going to look at the derivative of x to the n in a minute. So this is the new notation. So d over dx just means f prime. That just means your derivative. And instead of delta x, you're going to be using h. So it's the exact same formula, except for your delta x's are now h's. Whenever we're working through these, I don't care if you use the h or the delta x. It's up to you. So we're going to use the h notation for the definition of the derivative to find the derivative of the square root of x. So this is one that you definitely want to pay attention to and learn how to do this one. It will show up on your test, and it's one that you need to know how to work out. So we're going to start off with our formula. And I'm going to do g prime instead of d over dx of g of x. But if you want to write this out, you can. So our derivative is going to be the limit as h approaches 0 of our function f of x plus, well, it's not f of x on this one. It's g of x plus h minus g of x all over h. Okay, so now we're going to plug in our function. So our function is the square root of x, so it's going to be the square root of x plus h minus the square root of x over h. And so you may be trying to figure out, what are we going to do to simplify this? I can't combine those radicals. I can't plug in 0 because I'm going to be dividing by 0. The way that you want to do this one is to multiply by the conjugate of the numerator. Normally we don't want radicals in our denominator, but on this one we're hoping that by putting a radical in our denominator it's going to make it so that something will cancel out. So the conjugate, everything's the same except for the sign in between the two terms. And so that's a little trick that you probably wouldn't necessarily think of off the top of your head, but that's how you're going to work through this one. All right, so we're going to do limit as h approaches 0, and you're going to distribute. So the square root of x plus h times the square root of x plus h is just going to be x plus h. The square root of x plus h times the square root of x, I'm going to make plus, I'm just going to do square root of x, and then square root of x plus h. Okay, for the next one, we're going to have minus the square root of x times the square root of x plus h. And then we have negative square root of x times square root of x, which is negative x. Okay, so that's your numerator. For your denominator, you're going to have h times the square root of x plus h plus the square root of x. Okay, so that's distributing it. Now we want to try and cancel some stuff. So if you notice, this term here cancels with that one, and the x is canceled. So in our numerator, we're left with just h. And we're going to have h times square root of x plus h plus square root of x. And so now our h's will cancel, so that we're left with the limit as h approaches 0, 1 over the square root of x plus h plus the square root of x. And now we can actually plug in our h approaches 0. And so if we do that, we're going to have 1 over x plus 0 is just the square root of x, and then plus the square root of x. So that's 2 square roots of x, so we're going to have 1 over 2 square roots of x. And so you can leave it like that. I'm going to rewrite it in another way just so you can see in a minute where that came from. So square root of x is a 1/2, so 1 over 2 x to the 1/2. And if I want to make that a positive, I'm going to move it up. I mean, if I want to make it a negative, I can move it up and make it negative 1/2. So that's the derivative of the square root of x. 1/2 x to the negative 1/2. Okay, so that again is something that you definitely want to learn how to work through by yourself. Remember that until you actually plug in h approaching 0, you have to keep the limit. You have to make sure that that part stays there. Okay, so we're going to find the derivative of x to the n, where n is equal to 1, 2, 3, 4, etc. So we're going to use our same formula that we just used. So the limit as h approaches 0, f of x plus h minus f of x all over h. So this is going to be for n equals 1. So the limit as h approaches 0, if we have x to the 1 for our function, then we're just going to have x plus h all to the first power, which is just x plus h, and then minus x to the first power, all over h. So x minus x would cancel. So we're left with h over h, which is just a 1. And so the limit, when we plug in a 0 for h, well, there's no 0. We're just left with a 1. Okay, so that would be for n equals 1. For n equals 2, that would be, we would have x to the 2. So we're going to do the limit as h goes to 0, and we're going to have x plus h squared minus x squared all over h. Okay, so then from there, we're going to have, as our limit of h approaches 0, distribute this, you would get x squared plus 2xh plus h squared, and then minus x squared all over h. Your x squareds are going to cancel, and you're going to have 2xh plus h squared over h. And then from there, we can cancel an h from each term. And that would make 2x plus h. So we can plug in 0 for h, and that gives us just 2x. Okay, so that would be for those. And I'm going to make it small so that I can keep going with the next one. So now we're going to do n equals 3. So that would be x to the 3rd. So we're going to do the limit as h approaches 0. And we're going to have x plus h to the 3rd, and then minus x to the 3rd, all over h. So you need to distribute. So you would have x cubed plus 3x squared h plus 3xh squared plus h cubed, and then minus x cubed all over h. And your x cubes cancel, so that you have 3x squared h plus 3xh squared plus h cubed over h. Oops. And an h can cancel out of each term. And so you'll end up with 3x squared plus 3x, there should be a square there, h plus h squared. And so now we can plug in a 0 for h, and we end up with 3x squared. Okay? So that's how you would do x to the 3rd. For x to the 4th, hopefully after I do this one, you'll see, y'all may already be seeing a pattern. If so, guess what you think that x to the 4th derivative will be. Okay, so let's see if your guess is correct. So we're going to do the limit as h goes to 0, x plus h to the 4th minus x to the 4th over h. So if you distribute, you'll have x to the 4th plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the 4th minus x to the 4th all over h. And then from there, your x to the 4th will cancel. And so you'll have the limit as h approaches 0, 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the 4th over h. And then an h will cancel out, and you end up with 4x cubed plus 6x squared h plus 4x h squared plus h cubed. And then when you plug in a 0 for your h's, you end up with just 4x cubed. So does anyone see the pattern that is emerging? On this first one, we ended up with just a 1. On this one, the 2 came to the front, and there's no exponent now, it's just a 1. On this one, the 3 came to the front, and instead of it being a 3, it's now a 2. It was reduced by 1. So on this one, the 4 came to the front, and instead of it being a 4, it's a 3. And so that is called the power rule for derivatives. Your exponent goes to the front, and you subtract 1 from it. So if we're looking at the square root of x, that's the same thing as x to the 1/2. So if we take the derivative, we bring the 1/2 to the front, and then we have 1/2 minus 1, which is negative 1/2. And that's what we got on our first example. This is valid for any real number value of n. Now, one thing to note, whenever you are asked to find the derivative, you have to be careful whether it says to use the definition of the derivative or just the shortcut. So if it just says find the derivative, then use the shortcut. However, if it says use the definition of the derivative, then you're going to need to work it out like we did on this one, or like we did on this one, okay? So if it says use the definition of the derivative, that means you have to show all of your work. Now you can check it using this formula, but if it says use the definition of the derivative, then you need to have all of your work shown. Okay. So that's again called the power rule for derivatives, and it will become your friend when you learn it, because eventually it'll stop asking you to find the derivative using the definition of the derivative. All right, so on your homework, you need to do 1 through 25 tonight, and then we can go over any questions that you have tomorrow.